Hey Math 1B, I'm back with a new video. Again, this is a concept from chapter 3 of this year, so you have seen it before. It's an extension of factoring out the greatest common factor from a polynomial. This time though, we're going to be factoring by grouping. Now to give you guys some kind of solid rock to stand upon for this, I want you to go back to the polynomials chapter, where we would be multiplying things like, let's say 6a plus 2b, okay, times c minus 3d. Okay. Now, if you'll recall, what we did to expand this polynomial, multiply the two together, we would take the 6a and we would multiply it by everything in the second group. So you'd take it and multiply it by c minus 3d. Okay? We would also take the 2b part and multiply that by everything. So we would write out plus 2b times the c minus 3d. And that would give you 6ac minus 18 AD plus 2BC minus 6 BD. All right, now that seems pretty random right now, but I wanted to show you guys exactly what we're doing here. See, in this situation, we actually wouldn't have been able to combine any more like terms beyond that. But I wanted to highlight the fact that factoring is the reverse of distribution, okay? So it's basically like the distributive property where you multiplied through and then you got it down to this. Factoring is the reverse order of that. So here's what we're doing. We're saying you're given a 4-term polynomial right here. We want you now to work backwards to this step. Okay? And then we're hoping we've got sort of like this identical twin situation. And then if that happens with factoring by grouping, then we can move back to this step. And that will be our final answer, not this. Okay, so factoring by grouping is the reverse of polynomial multiplication, which is, it's kind of like saying, you can dribble a basketball forward. Now can you do it backwards by backing up with it? Maybe that was a bad metaphor, but let's just get into it, okay? So what we want to do here is instead of trying to find the GCF for all terms, which if you did try to find a GCF, you're not going to find it, you can just say, look at the two terms that come first, all right? So 15y minus 35. Let's just do prime factorization on those two right there and see what we come up with. So 15y and negative 35. 15 is just 3 times 5. So we go 3 times 5, put a y on the tail end of that. And remember, I'm putting a 1 every time, but I'm not going to circle the 1 unless it's the only thing they share. Now, negative 35, I'm going to put a negative 1 right away, times 1. 35 is 5 times 7. All right, check out what they share. They seem to share a 5, and that's it. So what we do is we say that 15y minus 35 is now going to be the GCF 5 times the leftovers. So we have placeholders for 15y, which is 1 times 3 times y. And then we have a placeholder for the negative 35, negative 1 times 7. Okay, so we have successfully factored the first group of this 4-term polynomial. We're going to do the same thing now with positive 9xy minus 21x. So 9xy and negative 21x basically breaks down its prime factorization to, this is 3 times 3 for 9, times x times y. Make sure you put a 1 at the front end. Negative 21x is negative 1 times 1 times 21's 3 times 7. And then there's an x at the tail end. Circle what they share. So they share a pair of 3's, and they share x. So that means that our GCF of the second group is 3x. And then the leftovers, again, we have two groups of leftovers. The first is 3y. 1 times 3 times y, 3y. And then negative 1 times 7 is minus 7. And really, I want to indicate that this was a positive 3x that we took out, all right? Because what you're going to see is we've successfully gone from that last move that we had. We've moved back a step. See how we had two groups of leftovers that were the same here? Well, look, we've got two groups of leftovers that are the same here. So now it's a matter of saying, how do we move to this group here, where it's two factors side by side multiplied? Well, it seems like these are almost like our GCFs if we were doing the factoring game. So now the GCFs, 6a plus 2b, are in a group of their own, okay? Those two GCFs. And then the two leftover groups become one, because it's just the reverse of the distributive property. So how do we finish out this right here? Well, we create our GCF group, which is 5 plus 3x. Again, 5 plus 3x multiplied by our two leftover groups. But again, those two came from one group if we went the opposite way. So it needs to be consistent like that. And again, guys, we saw how to do factor by grouping back in the first semester. So I think you guys will pick up on this a lot quicker than you might think. Let's try a few more examples. I'm actually going to show you guys how to do the examples without having to map out the prime factorization. We'll see if you guys like that better than doing the prime factorization. So we've got 3x squared minus 2x plus 12x minus 8. Now, one thing that I didn't suggest in the last example was that you are allowed to rearrange terms to make for better factoring. What I mean by that is, it seems to me that the 3x squared is a much better match for a 12x. I mean, I just see right away that 12 and 3, they both divide 3. So I'm going to actually rearrange that first. You're allowed to do that because of the commutative property. So rearrange 3x squared plus 12x minus 2x minus 8. Okay? So here's the new method. The new method is asking yourself, can I just figure out the GCF without doing that whole prime factorization business? And here's how you do it. You say to yourself, this group right here will have a GCF of, and then you ask yourself, what does 3 and 12 share? And hopefully 3 is coming off the top of your head like, oh yeah, they both divide 3, I get that. And then you look at x squared and x, and you ask yourself, what's the common theme between those two? Well, they both share at least one x, so the GCF is also going to have an x there. Now, what you can do with this now to determine the leftovers, the thing that's supposed to reside in that group there, is you can divide both parts of your group by the GCF. So you can say, okay, 3x is what I took out of those two terms. Since factoring is the reverse of the distributive property is multiply, factoring is divide. So you can actually divide and put your leftovers in the parentheses like this. So 3 divided by 3 is 1. X squared over x is x. So it's 1x. And I'm just going to leave the x blank like that. 12 divided by 3 is positive 4. X over x cancels out. Okay, so I didn't do any prime factorization, and I've got my first group. For my second group, I ask myself, what's the greatest common factor between negative 2x and negative 8? And hopefully it's like, well, they're both negative. So I'm going to be dividing both terms by negative something. They're both even, so they both share a 2. And then there's no x's that they both share. So the GCF, pretty quickly discovered there. Now negative 2 divided by negative 2 is positive 1. All right? And then there's an x on the tail end of that. So positive 1x is the same as x. And then negative 8 divided by negative 2 is positive 4. This is what you want. It shouldn't just be like, oh, what a coincidence. There's 2x plus 4s. It should do that if you're factoring properly in these situations. So we've got both of them are x plus 4s. You now do the last move of factoring by grouping, which is basically reversing the two binomials, the two-term polynomials. It's saying the GCFs go in one group, and then the leftovers basically combine to be one group. And I hope you guys can kind of reverse engineer this a little bit with your knowledge of polynomial multiplication. If you were multiplying 3x minus 2 times x plus 4, then it should look kind of like this. You are saying take 3x times everybody in the second group. Then you're taking negative 2 times everybody in the second group. And then you distribute 3x to both parts. You distribute negative 2 to both parts. And that's where the original polynomial came from. Okay. I'm actually going to make a second video to just share those last two examples on the homework. If you feel like you got a good solid read on this, then by all means just get started on the homework. But yeah, you might want to check out the second video just to make sure you're doing all the notes examples correctly.